if you remember back when we did chapter 12, we did stuff with square roots. Like we know that square root of 9 is 3, square root of 81 is 9, and so forth. But now we're going to involve some variables, and when you simplify these expressions with variables in them, with square roots, it's going to be a little bit different than what you may expect. So let's take a look at the first one. We know that square root of 81 is 9, right? Any question? Because 81 is a perfect square, right? It's 9 times 9 is 81, and of course, square root of 81. Now, let's do an example. What if I have square root of 162? Okay. Yeah. Okay, good. Let's go back to this. Now, can the answer be negative 9? No. No, it cannot. When do we get positive 9 or negative 9? That's when you have n? No, that's when you have n? Equation. Is this an equation? No. Guys, this is a positive number. Hello?
Expression.
Yeah, it's an expression. When you simplify a positive number, you get a positive number, don't you? But when would you get positive or negative 9? If you have, like, oops, x squared equals to 9 or something, 81 or something, right? Then what do? You take the square root of both sides, right, guys? Then we get what? Then that's why you get x equals to 12 to minus 9. Do you see the difference?
Nope.
No?
No. Yes. I did before, but now that
Okay. Okay. So when you have a positive expression, you get a positive number. When you simplify, when you're solving, you're looking for every possible solution. When you square it, that makes it to 81. And there are two possible ways for you to do that. You can multiply negative 9 times negative 9, or positive 9 times positive 9. That's why we get two solutions for this. Okay, please remember the difference. Today we're going to talk about expressions mostly. At the very end, we're going to talk about one equations, but it's something that we've dealt with, right? Solving equations that are square roots, right? We dealt this in chapter 12, right? We should all know how to do that. Today we're going to be concentrating on simplifying expressions that involves variables. So for example, before I even talk about the variable, if I have a square root of 162, how do we simplify this? Is this a perfect square, 162? No. So how do we then deal with this type of expressions? Two people, remembers? Okay. You do a factor tree, and you want to see whether or not we get a perfect squares, right, as a product. Okay. So everybody try a factor tree, see what you get. Okay. How many people got? I got 81, 2, 9, 9, and 3, 3, 3, 3, and 2. Right? Okay, good. So Anita, you think you need the answer? How do we simplify this then? Yeah, two 3's pair up, 2 3's pair up, and you got what's left? Yeah, 2. So what is your answer? 6 square root of 2?
That's wrong.
Wait, it's 3 times 3, so it shouldn't be 6. It should be 9, right? So, okay, you guys remember doing things like this? When the radicand, remember the number inside the square root is called radicand? Yeah. When the radicand is not perfect square, you do a factor tree to see if there's a product of a, if there's a factor of a factor of a perfect square, and then you simplify that way. Okay? Yeah, we've done this before, but now I'm telling you then, square root of x squared isn't equal to x.
It's plus or minus x.
No, it's not. You're not solving. So a lot of you may think, oh, isn't square root of 3 squared 3? But how come square root of x squared is an x? Yeah. What do you mean by that? What do you mean by you don't know what the x is? Because I mean, think about it. Isn't square root of 3 squared? Isn't that just 3? So if this 3 is x, doesn't that come out to be x? Yeah, Danielle? Not quite. Does anybody? So a lot of you may have thought that square root of x squared is x, but now that we're involving some variables, this is not true every time. So how do we show that something is not true? We do a counterexample. Can somebody give me a counterexample? Because it is really easy to show something is false. Berge.
If you have like a negative.
Yes, very good. If I have a negative, how about negative 2? Plug in negative 2 in here. What is square root of negative 2 squared? That is square root of, what's negative 2 squared? 4, right? What is square root of 4? 2. Does it come out to be negative 2? Because that's what this is saying. If it's saying square root of x squared equals to then negative 2. No. So that's a counterexample. If you plug in negative 2, right, it does not come out to be negative 2, does it? It comes out to be what? Undefined. What is the square root of negative 2 squared? It is square root of 4. And what is square root of 4, guys? You get 2. So this statement is not true every time. It'll be true if x is like 2, right? It'll be true if x is positive. But would it be true if x is negative? No. So how do we then represent this? How do we simplify square root of x squared? We know it's not this. Is there a way to write this another way? Anybody? Yeah.
X squared, or the square root of x squared equals plus or minus.
You cannot write plus or minus x, because if you do that, then you, okay, so
Well, equals x or...
if you do plus or minus x, watch this. If I plug in, I don't know, 2 in here, it's 2 squared, does that mean you get 2 solutions, plus or minus 2? Is square root of 2 squared plus or minus 2? No, it is not, right? This is saying square root of x squared, square root of 4. This is saying square root of 4 is negative 2 or 2. Does that make any sense? Is square root of 4 negative 2 or 2? No, this is wrong, right? So you can't do that. Yes?
Why did you cross out the 1 square and square 1 square?
Oh, this is because somebody said this was a counterexample. This isn't a counter. Let me just erase that.
Only equal one.
Somebody said, well, I asked people, give me a counterexample. They say, oh, what about 1 squared? Well, square root of 1 squared is 1, so that works. So that's not a counterexample. A good counterexample would have been this, negative 2. If you plug in negative 2, right, it becomes a false statement. So yeah, sorry, I should. Okay, so Brian, so then how do we represent this?
Would it be square root of plus or minus x squared equals x?
No, no. Berge,
What if you do absolute value of it?
that's exactly what I was going to say. Excellent. Okay.
Oh.
Berge, you got it right. So Berge, what do you think it should be?
Where should I like...
Square root of x squared n is equal to
absolute value.
absolute value of x is correct. Does that make sense? Why? Let's plug it in. What if I plug in negative 2 in here? Does it equal to absolute value of negative 2? Yes, it does, right? Because you get square root of 4 equals to 2. What's the absolute value of negative 2, guys? 2. Now, does it work for positive?
Yeah.
Of course it works for positive, right? What's the absolute value of a positive number? Positive. So that's how you do it. That's a very good observation. Excellent. Good job. Okay, any question? So it turns out if you have square root of x squared, it is not just x, but it has to be absolute value of x. Now, another clever person said this. Well, why not make it into 2 cases? Why not for case 1? What do you think the case 1 will be? Yeah. Where x is positive. Then what would if x is positive, it comes out to be just x. If x is negative, then it comes out to be negative of that x, right? For example,
Wait, can you go?
if I have, so as you can see, if I have, if x is positive, right, it just comes out to be square root of x squared equals x, right? But if x is negative, you have to make sure that you gotta multiply by negative 1, right? Because if x is negative 2, then you get positive 2 as the answer. Does that make sense? But which way do you like better? Writing in 2 cases every time you simplify, or using the short way? Using the short way. Isn't that better? Okay, so this is a lot better to just use the absolute value of x, right? So that the square root of x squared is absolute value of x. Does that make sense? So guys, do you see why it'd be wrong if you leave out the absolute value for this?
Yes.
Okay? Because it's not a true statement, is it? It's true for positive x's, but if x is negative, it won't be true. Right, guys? Okay, so if you know that, then try this one. Notice I use the same exact number as example 2, square root of 162x squared. Now I have x squared inside. See if you know how to do that one. Go ahead, everybody try. So first of all, we know that we could separate these. Remember? If they're all product inside of the square root, if in the radicand they're all product, we could separate these products, right? You guys remember? So could I rewrite this as square root of 162 times square root of x squared?
Yeah.
And do we know what square root of 162 was? Yeah, we just did that one. It is simply 9 rad 2. Isn't that right? What about square root of x squared? What is that? Yes.
Absolute.
That's right. How many people wrote this down as the answer? 9 rad 2 absolute value of x. Do you think you get this right if you didn't put the absolute value? No, you would get it wrong. Okay, so you want to simplify this correctly, you need the absolute value of x there. You get the idea? That's why it came out to be. Okay, so let's then try some other example. How about then since we know this, try this one. By the way, so let me write this down. When you are finding square roots of variable expressions, which is what we're doing right now. When you're finding the square root of variable expressions, you must be careful to use an absolute value sign when needed to ensure that your answer is positive. When do we use the absolute value? When you need to ensure that your answer is positive. Okay? So please keep this in mind. That's why we needed the absolute value of x over here, right? Because if you didn't, then if x was negative, right, your answer will be, the expression would not be equivalent. It would be wrong. Okay, they will not be same. They will not be equivalent. Okay. So if this is true, then knowing this, why don't you try this? Okay, everybody try. Square root of 400.
Yeah, it's very close.
I'm sorry. Square root of 400 z to the 6th power. Okay, Danielle, what do you think the answer is?
20 times 1, the absolute value of z to the third.
That's correct.
Yes.
Because don't you get square root of 400 times, watch this. Did you guys put this step in? It is really, z to the 6th is really something square. What is it square of? Z to the third. Because remember, when it's power to a power, you need to multiply, right? So it's something square. Well, we have to make sure then when it comes out that z to the third keeps being positive, right? So therefore, you need to put the absolute value. So that's the answer. Yeah. How many people got this right? Raise your hand. Okay, any question? If you didn't, do you understand now?
Yeah.
Any question here? All right. Okay. Why don't you try this one? Let's see if you really understood this. Because this one, you'll find this one a little bit interesting. Go ahead, try this. All right. How many people got 6 absolute value of x to the 4th? Raise your hand. 6 absolute value of x to the 4th. Okay.
Minos did not get that.
Oh, some of you didn't get this. How many? Raise your hand. Raise your hand. Okay. Right. Okay. That's how you get it wrong. Okay. Now, I claim to you that. Okay. First of all, you guys did the right work. If you leave this on the test, it's kind of right. It is sort of correct, but then you don't really need to. I'm claiming to you that this is all you need. How come this time I don't need the absolute value? Think about this. Because if you leave the absolute value, guys, you're not done simplifying. Why not, Sasha?
Because since it's to the 4th, it'll be positive for the
Exactly right. X to the 4th would always give you a positive number. Okay. Now, a lot of you are asking, so write this down. So when you have x to the even number of power, after you do all this, right? So this is after taking square root of some x, right? X to some power n. And then it comes out to be some x to the even after you simplify, right? So I could even actually do this. This is better. X to the some even power to the 2nd power, right? And don't they cancel out? So when it comes out to be x to the even, does not need what? What does it not need? That's right. Does that make sense? Does not need the absolute value. You write this down. Oops. You guys, do you understand? So if you're square rooting a square of x to the even power, of course it comes out to be x to the even, you do not need the absolute value. Okay. Now knowing this, why don't you try this one? This is what you guys been asking, right? What if you have the inside of the square root, you have odd power there, right? That's kind of what you're asking. Right, that's what you're asking, isn't that right?
No, but like.
Okay, we'll do this one first and then we'll answer your question. Try this. How many people think they have the right answer? Ferg. I mean, Getty.
I got